Jai Hind to all. In this video lecture, we are going to start statistical graphic, which is a part of Unit 3 HCI, okay, Human Computer Interface. Statistical graphics, why we use statistical graphing and what is statistical graphic? A statistical graphics is a data presented in a graphical format. So, whatever we present the data in the graphics format, graphic format has many features we will discuss in the coming slides, okay. So, whatever the data is presented in the form of graphics, either in the form of line graph, either in the form of the bar graph, either in the form of the statistical graph, either in the form of the surface chart and etc. So, we use the statistical graphics, okay. Why we use the statistical graphics? Because when the data is very large and we have to show the trend, the change in trend in the data, we go for the statistical graphics, okay. So, what is the use of statistical graphics? Statistical graphic reserved for material that is rich, complex and difficult. This is important here, the complex and difficult, where the data is very difficult to understand, to differentiate between the data, because there is large amount of data, we go for the statistical graphics, okay. So, we use here statistical graphic for data presentation. The main motive of the statistical graphic is data presentation, because we emphasize the data in this. And the next is minimize known data element. So, known data element which are irrelevant, we will use it minimize, okay. So, next minimize redundant data. So, redundant data will be minimized, we use the consistent data removal, okay. Next, fill the graphs available area with the data based on the labeling, based on the space and based on the data. We will differentiate between the data based on the amount of data we have. So, in coming slides we discussed how we differentiate between them. Show data variations. So, as I told, because there is large amount of data, we have to show the data variation, we go for the statistical graph, okay. And next is provide proper context of data interpretation. The proper context, if you want to find between the data, you will go for the statistical graphics. So, next, scales and shading. So, when we draw the statistical graphics, we have to use the some scalings and some shading. So, let us discuss what are scalings and shadings, okay. The first is place tick to mark scale on the outside edge of every axis. So, whatever axis we take, we have to scale. Suppose this is the x axis, this is a y axis. So, x axis represents, suppose, number of month, okay. So, here we do the scaling, and this is the item sold during year, okay. So, this is the scaling. Next is employ linear scale. Here we provide the x axis, the linear scale and the horizontal scale. So, both scales are linear in the x axis and y axis. Next, start a numeric scale to 0. We have to start here 0 based on data, whatever data we have. If we have large amount of data, we will divide it into 100. If we have thousands of data, we use the 1000, 500, 600 based on the whatever data we have, okay. Next is display only single scale on axis. Only one axis we have to use the one scale, and on the other axis we have to use the other space, okay. So, we can't here, this is 100 and this is again 50. So, this scaling will be different, or this scaling will be wrong here. So, you have to use the same scaling on one axis. Provide scaling consistency. So, if we use the equal amount of data through the axis, one axis, so we provide the scaling consistency here, okay. Next, consider duplicate axis for large scale. So, we can use sometimes duplicate axis for large scale data. Suppose we have the 3-dimension data. So for that we have to use the z-axis also, but this is the 2-axis screen. Okay, here we have the x-axis and y-axis, but our data is in the form of the 3-dimensional. So in some time we can use here the z-axis also. Okay, and the proportions we have to use the equal proportion. Lines, okay, we have to use a line. So most important point is here labeling. Whatever curve, whatever data, whatever bar graph you use, you must do the labeling so that user can understand to see the graph what about for the graph. Okay, and next is title. We have to give the title of the whole graph. Okay, so that at first impression we can understand what is the deal for, what's the graph deals for. Okay, the next is interpretation of numbers. So numbers must be interpreted. Okay, if thousands of data, so we have to convert it into 100, 110 times. Okay, this 100, based on that we make a curve or a line or whatever the types of statistical graphic we use, we have to do it, and after that this curve will be converted into the in the form of 100. Okay, so suppose this is 100 or this is here 160, okay, or 120 suppose. So this is the 120 and this is again up 200 and all that. So this is the important part to draw any statistical graph. You have to make the text, you have to employ a linear scale, you have to make scale at a standard or customary intervals. This is important. Start a numeric scale always with the 0 axis and start display only single scale on 1 axis. Provide scaling consistency. Consider duplicate axis for large scale data. Proportion, the graph should be equal in proportion. The lines should be equal in proportion. The title of the graph and the interpretation of the number. So let's discuss the types of statistical graph we can use. Okay, the first graph is the curve graph and the second graph is the line graph. Here you can see that these are the labels. Okay, so the curve will start from here 0. Okay, this curve will move like this. So this is actually nothing but the large amount of data which is vary from time to time. Okay, so if at this point this is vary, okay, at this point this is vary, at this point this is vary, at this point this is vary. So how you can check this is the variation? You have to find the tangent at any line. Okay, so you can see that in case of the curve, at every point you find the different tangent. So that means there is a continuous change. So whenever the data is continuous change, we have to go for the curve graph. Okay, because in curve graph at every moment you can see here the tangent is different. The tangent is different means the data is changing continuously. Okay, so whenever there is large amount of data and the data is changing continuously, at every point you find the different tangent, so you can go for the curve graph. So next is the line graph. Okay, when data is changes in interval, not regularly, not continuously, if data changes in intervals, you can go for the line graph. So here the number of houses sold, show the y-axis, and the number of months, show the x-axis. Okay, so in January 50 houses were sold. Up 50 can be 500. Okay, this if it can be 500 if we have taken the scale 10. Okay, at February it will 30. Okay, at March it will be 40 and it will be 30, 20 and the 50. So you can see that from one month to another month, here the data we have taken the month wise. Okay, so first suppose we have taken the 30th Jan and then 28th February and then 31st March. Okay, so here At the end of month, we have to collect the data and we put it into the line graph. So based on that, when we join all the point from month to month, you will get a line. Okay, so line graph are used where the data is changes in interval, not continuously. So next is single graph. So what is the single graph? Single graph, we can use 4 or 5 lines maximum. Okay, so single graph is a combination of the line graph. Here not a single line present, here 4 to 5 maximum lines are present. Okay, so label identification, for every line you have to do the label. Okay, suppose this is predicted x and this is the y. Okay, then legends. What are the legends? And tightly pegged curve, and important or critical data, and comparing actual and the projected data, and we have to find the data difference. So if you find the difference between the two curves, okay, if you comparing the actual and the projected data, you will go for the simple or single graph. Okay, so single graph, as the name single means one graph. So one graph contain multiple line graph. So multiple line graphs, when we have to compare the multiple graphs, multiple line graph, we can go for the single graph. Okay, so here the curves are always tightly packed. Okay, label identification, 4 to 5 maximum line graph in a single graph you can use here. So why we use single graph? We have to, if we want to compare the data and if we want to find the data difference, we can go for the single graph. And the next one is the surface chart. The surface chart, as the name suggests, surface is in the 3 dimension. Okay, so surface is what ordering you have do, what coding schemes you use, and what labels you use to draw the surface. Here is the surface. Okay, so the labeling is 0, 3 dimension. This is the one axis, this is the second axis, and this is the third axis. Because surface has 3 dimensions, so based on 3 dimension, we have to label the 3 axis here, the first, the second, and the third axis. And based on the coding scheme, we find these. Okay, this is the x-axis, this is the y-axis, and this is the z-axis. So based on 3 axes, we find the surface chart. Okay. Next, scatter plot. This is another statistical graphics. Statistical proof, as the name suggests, scatter plots. So scatter means scattered, bikhra. Okay, scattered. So here we find some data are scattered between the 2 axes. Okay, this is the height, this is the weight. Based on height and weight, we find some data here. Data highlighted here with the blue dots. Okay, so scatter plots are always in 2 dimensions. Okay, if we use the consistent interval, we can go for the scatter plot. And multiple data set, if you are using, you can compare with the scatter plot and the significant plots. Okay, so basically for example, you find the clustering of data. So you plot the scattered graph, and based on that, if there are more than dots are present here, you can make this one cluster. If another scattered here, you can make the another scatter. Okay, another cluster. So in clustering, mainly we will use the scatter plots. So in many ways you can use the scatter plots, but this is the one example here. If you find the clusters where the maximum data used, you can go for the scatter plot. Bar graph. Okay, so bar graph is the consistent orientation. You can see here there is a consistent orientation. Okay, the same interval you use for every bar. Okay, that's why it is called consistent orientation. Meaningful organization. Okay, so for every curve every bar there is a meaning. Bar spacing, you can see here there is equal bar spacing between the two bars. Okay, you can see here. And differentiation, you can find the differentiation between these two bars based on that bar. Important or critical data you can use here with the help of bar graph. You can compare with the help of bar graph the different and important data. Next, relating bar ordering. Okay, you can use the ordering here, the 1, 2, 3 and so on. And reference index. Okay, so here reference index is the apple, orange, banana, blueberry, grapes, and here the number of people use these fruits in a one day. Okay, so based on the use we have to find the nicest fruit. This is the title of the graph. So you can find the nicest fruits is the blueberry because 40 people will consume in a day. Okay, so this is the how the data will be interpreted using the bar graph. Okay, now labeling, we have to do the labeling, we have to do the reference index. So this is all about the bar graph. You have to, if you compare the data in equally, okay, in month wise, or you can say that the fruit wise, or you can say the equal interval. When we have to go for the equal interval, we can go for the bar graph. Okay, based on that we have to do the comparison and find the actual value, best value based on this bar. Next is segmented or stacked bar. Segmented or stacked bar is used for categorize the data ordering. Okay, here you can see the bar. Okay, where equal spacing between the bar. This is like the simple bar we used in the previous slide, but you can see here this is the color difference between a single bar. Within a single bar there are 4 colors used. That means this is a segmented or stacked bar. Okay, stacked means one upon other. Okay, blue, red, sky blue and the green color. So segmented graph use within a bar how much data used here. Red color represent the different taste or different data within a stack. Okay, suppose we have the 100 data. So in 100 we have to categorize these 100. Okay, suppose here if we use the 5 and then 20 and then 50 and then 25. Okay, so here we have taken this 100 will be converted into the different category. Based on that we have to find these segments of a bar. Okay, so based on data category, what data category we are using, what ordering we are doing, large segment of data and the coding schemes we use, and what are the labeling we done here. Next is the most important use in the coding, that is equal to flow chart. So flow chart is used to find how we have to move. Okay, what are the steps we have to follow, what are the order of steps, what are the orientation, coding conventions, arrows, highlighting and one decision at each step. This is the very much important point here in the flow chart. So in the flow chart you have to move one step ahead. Okay, so you have to decide from which direction you have to move, and the consistency, order and the word all choices. So let's discuss. This is the start. From here you start and then read A, B, C. Okay, so in flow chart every section is given in the rectangle, and this diamond is used for the decision box. Okay, so you have to go the left side or right side. So then if A is greater than B, you have to move the, if yes, you have to move in this direction. If A is less than B, that means you have to move in the next direction. Okay, again there are decision box. If decisions are yes, you have to go in this way. If decisions are wrong, you have to go this way. And again here you have to decide if decisions are accurate, you have to go here. If decision are wrong, you have to go here. And if both are decision wrong, that means you have print C. And finally you have to stop. If not, then you have to move like this, print A and print B. Okay, so this is the flow chart to find A is greater than B and out of 3 number which is greater basically. Okay, so flow chart have some conventions. So based on that convention, everything has its own meaning. The arrow show the flow of data. Okay, the starts and stops are always from this oval type. Okay, these are the input and output box, and this is the decision box, and every arrow will have meaning to move forward in from the decision. Okay, so flowchart are used mainly in C programming or whatever programming, in whatever language you use. So basically we have to, if you are making a coding, okay, in any language, in any schemes, so based on that coding, whatever you want to build, you have to make firstly its flow chart, how these steps are going one by one. Okay, so next is ordering of screen data and content. Okay, how the screen data and content are ordered so that more users will attract. Okay, and more meaningful data we will display and more user friendly we have to make our screen. Okay, so the next topic is ordering of screen data and content. So divide information into unit that is logical and meaningful. Okay, so basically if there is large amount of information you have, so convert it into, divide it into the logical units. Okay, and then organize by interrelations between data or information. Okay, these logical units are organized by their interrelation between data or information and provide an ordering of screen unit of element depending on the priority. The first important thing are prior and the next important thing at the secondary. So what are the possible ordering scheme? The first is the conventions of use, sequence of use, frequency of use, function of use, importance and journal to specific. So let's discuss these. Okay, frequency of use. So based on how many people are, how the data is frequently used, we have to design at the front. Okay, so frequency of use is a design technique based on the principle that information item that used most frequently should be grouped at the beginning and the second most frequently used item grouped next and the third most important item grouped next. Okay, so at first we have to group the most frequently used at the beginning and then this conventional. So conventional use, that means we have to use day of week by month of year and okay, month and the year. This is convention. So every time when we fill the form, you will see the conventions. Firstly you have to put the day and then the month and then the year. Okay, so these are conventions when ordering. So through convention and custom, some ordering schemes have evolved for certain elements like the date, okay, the day, the month and the year, or by name, okay, name, address along with its time. Now these elements should be ordered in a customary way so that it will be convenient for every user. Next is sequence of use. So every time there are convention of sequence of use. Suppose you have to find the address. Okay, so firstly you have to put the street name and then city name and then state name and then zip code. So based on that format, based on that sequence, you find the any address. Okay, so this is the sequence of use grouping involve arranging information item in the order in which they are commonly received. The term commonly received is very important here. okay, or transmitted or in natural groups. So an address, for example, is normally given by the street name, city name, state name and the zip code, okay. So next is function or category. So information item are grouped according to their purpose or by some common parameters. So all item pertaining to insurance coverage, for example, may be placed in one location, okay. The same functionality or things are placed in one location, okay. So transportation vehicles may be grouped within the category of planes, vehicles and automobiles, because all the three, planes, trains and automobiles, have the functionality to take the passenger from one place to the other place. So these are the transportation vehicle, all transportation vehicle, okay. So because all three have the same functionality, so such grouping also allow convenient group identification using heading for the user. So user go for a website, okay, to find the transportation vehicle. So user can go for the transportation vehicle and under that it will find the three options, the by plane, by train or by automobiles, okay. Based on that, the user decide based on fare and based on time and based on the convenience, user will decide he will go for the plane, for trains or for automobiles, okay. But firstly user go for the transportation vehicle, okay. So transportation vehicle under contain planes, trains and the automobiles, okay. And sometimes we use the subcategory and the subheading to find the ease of the user. Next is importance. So important grouping is based on the information importance to the user, task or the need. So important items are placed first or in the most prominent positions, and the item may be organized from best to worst. This is the very important features, the best to worst or the largest to smallest. So this is the way the data are organized based on the importance. Next and the last one is the general to specific. If some data is more general than other, the general element should precede the specific element. Suppose transportation vehicle, this is a general term, okay. So transportation by train, by plane and by automobiles. So these are the specific thing and this is a general term. So we have to go from general to the specific. So this will usually occur when there is a hierarchical relationship between the data elements. So this is common website organization schemes generally use this general to specific, okay. At first when you visit any type of website, first interface will show the general information and based on that general information you will go for the specific. For example, if you are visiting a college website, okay. So college, at first interface you just see the all the departments, and suppose you have to find the IT department, okay. You just click the IT department and then you have to find the IT department faculty and then you go for the IT department faculty. So basically from college to you will move to the IT department, and IT department you will move to the IT faculty, and in IT faculty you will go for a specific faculty. So here is the convention from general term to the specific term, okay. Now let's discuss another topic, visually pleasing compositions. So how we make our interface so that this is visually pleasing to the users, okay. So provide visually pleasing compositions, we have to following some qualities. What are these qualities? Basically, these qualities are the balance, symmetry, regularity, predictability, sequentiality, economy, unity, proportion, simplicity, and the grouping. So let's discuss quickly. This is the balance. Okay, so here you can see this is the balance and this is the instability. So what we choose for visually pleasing, we will go for the balance. Next, symmetry. Here you can see the symmetry. Here this is asymmetry. For visually pleasing, you will go for the symmetry. And predictability, this is the organized data. Regularity, and this is irregularity. For visually pleasing, we will go for the regular. Okay, so this is the predictability and spontaneously. So both these you can go for the predictability. Sequentiality. So what sequence of items we have to put here based on the eye, because the eye trained to be attracted to a brighter element before a one less bright, isolated item before the group, graphics before the text, color before the black and white, and highly saturated color before less saturated color, dark area before light area, a big element before a small element, an unusual shape before a usual shape, and big object before a little object. So based on that, we have to sequence the buttons. We have to label the button so that it will attract our user. Okay, so this is the unity and this is the fragmentation. So based on this, we have to go for the unity. Okay, so this is the visual pleasing proportion: small, large, 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 and large. Okay, and this is the simplicity and the complexity. So simplicity is more visually pleasing for us. Okay, so thank you everyone. Hope so you will understand the topic. Thank you so much.